Hello everyone and welcome. In this video, we will talk about one of the most critical concepts in fire and life safety design, the capacity of means of egress as per NFPA 101 Chapter 7. This topic actually is often misunderstood, and mistakes here can directly impact the life safety. So, in the next few minutes, I'll walk you through the logic, not just code numbers, so you understand why these requirements exist and how to apply them correctly in real projects. Let's start with the basic concept. The means of egress capacity is about answering simple question. Can all occupants leave the building safely within a reasonable time using the available exits, corridors, doors, and stairs? Capacity is not only about how many exits you have, it is also about how many people those exits can actually serve. Let's now move to the concept of the means of egress components. The means of egress components consists of the exit access, exit, and exit discharge. Capacity requirements apply to all these parts, including the means of egress components, doors, corridors, ramps, and stairs. The general rule here is simple. The total width of the means of egress must be sufficient for the occupant load it serves. NFP 101 provide unit width factors. These factors convert widths into number of occupants. For example, stairs typically require more widths per person than level components because movement on stairs is slower during the evacuation. On the other hand, the capacity of means of egress should be based on the minimum widths as per NFPA or the occupant load calculation, which is greater. The minimum widths mentioned in Chapter 7 for stairs and other egress components like doors, ramps, and exit access corridors. This is basically for the new build, existing buildings, and also there are specific conditions in which the requirements might be different. The second method to determine the exit capacity is the occupant load calculations, which depends on the exit capacity factors as per table 7.3.3.1, which is basically determined according to the occupancy and automatic sprinkler system existence. Now, let's talk about the unit width factors. In NFPA 101, the required egress width is calculated using specific widths per occupant as shown in this table. For stairs, the factor is higher. For doors and corridors, the factor is lower. This means that the stair serving 200 people will need more width than the corridor serving the same number of people. This is intentional. Stairs are bottlenecks during evacuation, and the stairs to accommodate the occupant load and the congestion on stairs is one of the biggest risks in the fire scenarios. Now, important point that many designers miss is the capacity is cumulative. This means that when multiple spaces discharge into the same corridor or stair, the occupant load must be added together. You cannot size a corridor or stairs based only on one room. Now, before we calculate the capacity, we must first understand the occupant load. The occupant load is the number of people assumed to occupy space. It is calculated by dividing the floor area by the occupant load factor, which depends on the use of the space. One of the common questions is which factor can I use? So let's take an example. A ballroom in hotel. The ballroom could be used as standing area or even non-concentrated seating area with table and chairs, which will take more space. The occupant load factor should be most stringent one in that case. Now, what is the difference between the net floor area and gross floor area? There is a specific definition in NFPA 101 Chapter 3. The net floor area is the floor area within the inside perimeter of the outside walls, or the outside walls and firewalls of a building, or outside and or inside walls that bound an occupancy or incidental use area, with deduction for hallways, stairs, closets, shafts, thicknesses of the interior walls, columns, and other features. The gross floor area is the floor area within the inside perimeter of the outside wall, or the outside wall and firewalls of a building, or outside and or inside walls that bound an occupancy or incidental use in area with no deductions for the hallways, closets, thickness of the interior walls, columns, or other features, but excluding floor openings associated with atriums and communicating space. So, what about the occupant load factor for mall structure? It is based on the gross leasable area as per figure 7.3.2.1. Here, this graph shows how to determine the occupant load factor for the mall structure. It is based on the gross leasable area mentioned here, and the other side is the occupant load factor. The maximum occupant load factor is 5.1, and the minimum is 2.8 square meter per person. Now, let's take an example. For a floor area including different spaces like conference room, call center, office space, small meeting rooms, each of them should be calculated based on the different occupant load factor. For example, the conference room should be based on 1.4 square meter per person after excluding the cabinets. The concentrated business use, which is the call center, calculated based on 4.6 square meter per person. For the open office space, it should be 14 square meter per person. However, for the small meeting collaboration rooms, it is different because it will be 2.8 square meter per person. Now, the total occupant load could be divided to the available to exit stairs here. Using the factor of 7.6 as per the exit capacity factors mentioned in NFPA 101 Chapter 7, we can determine the width of the two exit stairs by multiply the total occupant load to the exit capacity factor, which is 7.6. Each exit stair will be 1512.4 millimeter for each of them. Let's address a very common question. Are we counting people twice if they cannot be in two places at the same time? For example, in an office area building with a meeting room, which the employees are either in the offices or in the meeting room. So why do we size the egress for both at the same time? The answer is very simple. The codes assume worst credible use. Once a building is constructed, it's very difficult to control how spaces will be used over the time. The meeting room could be used for visitors or as external training space during the working hours. Because of this, life safety codes require egress capacity to accommodate the calculated occupant load of all spaces simultaneously. There are exceptions, but only when the authority having jurisdiction agrees on that. Examples include highly controlled environments like prisons or secured facilities. In such cases, the authority having jurisdiction may allow adjustments using equivalency provisions. But without the authority having jurisdiction approval, you must always assume the full occupant load. Now, let's talk about the distribution of egress capacity. Having enough total width is not enough. The capacity must be properly distributed. If one exit is blocked, the remaining exits must still handle the occupant load. This is why codes limit how much occupant load can be assigned to a single exit. Typically, no single exit should serve more than 50% of the occupant load unless specific conditions are met. This requirement improves the redundancy and resilience of the building. One of the common mistakes is how to measure the exit's components widths, which will be covered in the next video. Another frequent issue is forgetting to include the mezzanines and intermediate levels, which can be increasing the occupant load and the exit capacity as well. Now, Let's summarize the key principles. First, always calculate the occupant load correctly. Second, size all components based on the occupant load. Third, apply the correct width factors for stairs or other level components. Fourth, ensure proper distribution of exits so no single exit is overloaded. And finally, coordinate early with the architects, engineers, and authority having jurisdiction to avoid the redesigns later. To conclude, means of egress capacity is not just a code exercise, it is life safety responsibility. Understanding the logic behind requirements helps you design safer buildings and defend your design decisions with confidence. Finally, thank you for watching this video, and I hope this explanation helps you approach egress design more clearly and professionally.